and the answer is actually on slide number two on here. So the answer is right down there at the bottom for you. Okay. Uh, du- 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 du. Next time. Hopefully, I'm recording the slides as well. Okay, good. Right. So basically, they help us to be productive in the sense that things like right now, things that are paper based, you can write on Word, and if you make a mistake, you can delete it. Has anybody seen a typewriter machine before? If you made a mistake on an old typewriter machine, sometimes you have to tear the whole paper, throw it away, or just cancel it, go backwards, people say it. Pretty much right now, you are in your home, I'm here, or you're on campus, I'm here, we are still communicating. So some way, somehow, they do help us to communicate more effectively and be more productive. And of course, it gives us access to vast amounts of information. So, for example, just now, as I was illustrating things, think about it. I went on YouTube, I've gone on Google, I've shown you images, you've seen some things that probably in the past you probably have to go to museum or have to bring a physical thing to show you as well. So they make life easy. And because we use these things, it becomes more intuitive and we just have to think about it more effectively. In terms of transmitting and receiving data more quickly, it's happening right now as we talk between you and myself on Zoom, for example. So let's look at the types. So we've got the information systems. Let me push things away. So just thinking about different types that we can have. So we've got information systems, we've got the control system. So information just providing information. The control giving you some form of control of the devices or things that are connected to the ICT system. And we do have the communication systems as well. So let's look into each of these. So basically the information, sorry, was there a question? Okay, so basically the information one is focused on data itself, right? The data, like as we're talking right now, data is the stuff I'm saying. If you save it in audio format, for example, is the words that are coming out, is the actual content of the information that you're looking at. So the managing of the data, things like storage and other things, and of course, managing of the information content, right? So we've got an example here. So things like if you have sports club membership, if you go to the gym membership management, or even things like student attendance management systems or student management systems, we just basically storing information, making use of the information. If you're storing stock, what do we have on the shop or how much is left? It's more about the information. It's more about the data in that sense. And again, for control systems, we did talk about some things. So things like if you have some form of inputs, do some form of processing. We've already used the word processing when we talk about a computer, and also some form of outputs on there. So I'll take a typical example. Hopefully you can see. I don't know, randomly is the easiest I can think of. I do have a robot car here. So this robot car is got like ultrasonic sensor. It's got a sensor in front of it. So it can program it in such a way that as the car move around, if there is an obstacle, it detects some form of input. The sensor is the input. So if something block the sensor, it will make some decision processing, make the decision, turn around and go forward. Then the output will be the this that will move around, right? Like the wheels that's going to move. The same other form of robot, you may tell a robot, I don't know, you can tell a robot something, or Alexa, turn off the light, for example. So the input going into Alexa will be your voice. The processing will be what does turn off the light mean. So natural language processing the words you said to Alexa. Then the output will be the light that will be turned off. So you have some form of information going in, some form of making sense of the information and an action taking place. So it's controlling something. So far we've touched on information, we've touched on control, and then we're going to touch on communication. So communication has to do with sending the information or the data from one point to the other, right? So if you think on here, the example was maybe student management system storing the information, initiating some form of control, but in here, sending information across. At the moment, we are communicating. I'm sending something. I can see someone busily writing, for example, which is basically taking the information either on the screen or what I'm saying and then sending it across. I say someone writing, she smiles. I see that, at least I know she heard it. So I know in some one way or the other, without even using words, she's also transferred information from her location to mine as well. So continuing, right? So we've got input, outputs, and then other system diagram. We've talked a little bit about inputs as well. But input output, we've used some diagrams to talk about it, but I'm just going to talk through this slide for the sake of your revision and other things. So basically, let's go straight on into things. Talking about taking input, basically the instructions, like the robot, when we looked at it, some way, somehow, is the input here was just what the obstacle. And then, of course, in terms of the processing would be, okay, if I encounter an obstacle, what should I do, right? The same way, if I type an S, it may mean something. Before the break, I think someone put something in there that someone put thanks for whoever sent the message, thanks for letting me know. Someone put something in there, press Alt F, or something wonderful will happen on your computer, for example. With that input, there have to be some form of processing, and of course, that will produce the output. And you can't store the information, or you can just make use of it straight away, right? Things that people talking about garbage in, garbage out. We're not going to spend too much time on garbage in, garbage out, but we can just talk more about it as time goes on. So basically, if you have higher quality information coming in, most likely you're going to have higher quality output on there. I've got some people saying that they're having network issues, for example. So imagine if I also had network issues on my end, it would have been very difficult for us to have this session going on. So if we are given faulty information, obviously the system cannot function properly. Not just faulty, inaccurate information as well. Then basically we wouldn't expect the output to behave as expected. In that case, you are going to get errors in the output or more or less useless information on the other side. So that is why it is important that we validate the information. That's basically we make sure that what is coming in is the right information. Validation, just cross-checking, emphasizing or making sure that what we are providing to the system is correct. So we look at a system diagram, for example, and earlier we talked about the user. Luckily, we've got things marked on there. So we've got a user. If we have a bunch of IT equipment or computer equipment, for example, we have different users on the system where we can have one user, even some of them being main users or super users or administrators, for example. And if you go within these computers, we've got things like memory, we've got things like the hard drive, we've got things like the processor. We've seen some of these images in earlier discussions, right? So for the ICT system, if we take the user, of course, the person using it, the processing, we've talked about it, communication too, we've talked about it. So we've done well, covered quite a lot. The input being the data that is coming in, the output being what you are seeing on the screen or what is coming out to you, or things like printing emails that you're getting. Storage, we've got things like the random access memory, which is just basically temporal storage, or you've got things like hard drive, or you've got things like memory sticks or memory drives, or things like USBs, which stand for Universal Serial Bus, but mostly people call flash drives and other things USBs. So pretty much just the basic components that form this particular system diagram. So basically a system is just basically the parts coming together, right, to form a whole system for you or the whole ICT. So it's just little things fixing together to form it for you, right? And you can say that different ICT system, you have some of these or you have all of them together, working together. Just as we said, we have even one that we are using to communicate on Zoom now. Doesn't necessarily mean that you always have to have all these different components laid out, right? We've touched on the inputs and outputs already. So you've got a feedback system, and we say you've got some inputs, you've got some outputs, like we drew for earlier for a computer, for example. And this is the system. We've previously looked at what a system is, the whole part coming together. But in this particular system, it's more like an open system. There's no feedback coming in. So if, let's say, you consider this as the heating system in your house or in your room, and you say you've got a heater So I don't know how would I draw a heater. Let's say we've got a heater. Let's make it a radiator, right? That may work. So you've got a heating system in your house, and you go on there where they have some tiny little device on there. You set it to 30 degrees because it's cold and you want it to be a bit warm in your room. You set this to 30 degrees, and this is your room right now. If the room gets too hot to the point where you are sweating, sorry, this is the best drawing I can make of a person. If the room gets too hot to the point that you are sweating, this open system has no idea of how hot the room is. It will just keep heating until whatever is meant to say is 30 degrees is 30 degrees, right? However, if we set it in such a way that we say, okay, 30 degrees, but we have another sensor, which is probably just a thermometer sitting on there. This sensor says that if it is too hot, just simply switch off the heater for about 5 seconds until it comes down to the right 30 degrees again, and then it measures it. So even if it's very sunny outside and that contributes to the heat in the room, this room will normally be kept to 30 degrees. So the first one was open loop. It has no idea of the room temperature. The second one takes feedback from the room. So it actually takes information back from the room into itself as an input to say, actually, the room is hot enough. So let me do something about it. So in here, the first option, time is continuous. It doesn't come back. And with feedback, it takes information from the output, like what we have seen, back into the system in order to make further decision. Are we okay up to this point? If yes, please put a yes in the chat window. Good. Thanks for all those who are with me, awake and responding. I think this is just a typical example. We've already given ourselves an example. So when you get to this slide, that's what you'll be looking for. I've explained it differently in different times as well. So feedback can actually occur in ICTs as well. So if you have the types of ICT that we looked at the information-based ones. So the ones that store information means feedback can occur in them as well. So the outputs will just be taking information back into the system. And I think it's just a repetition of the stuff that we have already explained. So we've got a bunch of questions to answer. Then we give ourselves a very quick break and we'll come back and we will kill it as well. So you can have a pen and paper or even on your own Word document, answer these questions to yourself. I normally don't give the answers to these ones, but sometimes I do as well. Right. So the whole idea, we're not going to do this, is to compare the answers. First, answer it for yourself first, and then we'll see. Question number 1. Are you ready? Somebody say yes, and I'll read it for you. Are you ready? What does ICT system consist of? You've already answered this briefly. Does it consist of hardware, data, networks, and people? Hardware, software, data, people. Hardware, people, storage, and software. You've already answered this. You should know the right answer to this by now. Question number 2. At what speed do ICT systems transmit and receive information? Is it really slowly, rapidly, or quite quickly? Just pick the best answer for yourself and keep it. Don't tell everybody, let them also work. All those answering well done there. But let them work for themselves too. All those who are dozing off or eating a in Banku and other things, right? Or, I don't know, anything fancy. Right. Question number 3. Which of these is an example of communication technology? Is it a printer, scanner, or the internet? It's like you really want to help your classmates out. Right? Good. Okay, let's carry on. Question number 4. Can I continue? How do ICT systems differ from manual systems? Are they less productive, more productive? Hmm. I think you guys know each other too well, right? Okay, you're very kind. What is an information system's main management task? I'm not going to say right or wrong answer. I'll keep it that way. Data and information, data and people, data and machinery. You're talking about the information system type of ICT. Question number 6. Which of these is an output from a control system? Paper reports on industrial process, formula from spreadsheet, instructions sent to machinery or equipment. Think of it as a control system, okay? Control, control. And there was silence. Finally, yay. Just kidding. We are on this question. Which of these is an output from a control system? Sorry, do you want me to make the question bigger? Is that what you said? Somebody made a request. I didn't hear. Control system. Can I repeat? So yeah, so the request that stands out is repeat what a control system. So information, you're just storing information or managing the information. Control, you are just taking in some form of input, you're making some form of decision, and you are making an influence on an output. So an example that I use would be Alexa, turn the light on. You see the output happen. You see a change on the output if the lights come on. If Alexa cannot turn the light on, you just say, sorry, I cannot help you that this time. Or sorry, I don't know that. Does that make sense? Yeah? Does it help? Yeah. And the control, I don't know, we've also used the example of a robot. Just some form of do something. Control. If you control someone, you manipulate them. Right. Okay. Don't say I ever say that. Right. So, do you have your answers? This is why I hate recording sometimes. Do you have your answers? Good. Question number 7. What is the process? What is the process known by which output affects an input? We talked about that recently. You take the output and it affects the input. So we were on this question and I crossed this out. Do you want me to read it again? Question 8, you pick your answer. Then I'll read question 9. I like the way some people answer straight away. The question number 9. In what order do ICT systems deal with data, right? Is it, why do I keep doing this? Sorry, let me cross them out. Is it A, you process the data, you give the input and you give an output? Or is it B, you provide an input, then you provide an output and you process it? Or is it C? Huh? Do we most do we mostly agree C now, or the B people are still strong on B? Sorry? Oh, do we agree that the C people win, or C? Okay, good. Think about the way I described the computer, right? An input comes in, some form of decision is made, the processing, then you get an output. I said I won't be answering. Why am I answering? People stop me from when I start answering. Okay, question number 10. What is the short? Good. Giggle. I didn't talk too much about it, but it's the garbage in, garbage out. Yeah, I didn't talk too much. I think, to be fair, I didn't talk.